Kia ora, Marla, and thank you so much for the kind introduction and Jared for the invitation to speak. And yeah, I was aware looking at my own title that it's quite ambiguous and perhaps an overpromise, but let's see. I think it's going to be fun. Um, Rigor and joy in maths. And I'm also aware that holding on to what matters most is, there's an implied values judgment in there, right? Who gets to decide what matters most? And probably nobody really gets to decide. But my hope for this session was really to prompt some reflection, because I feel so I'll introduce my role shortly, but I'm in a school of teacher education in a university, and it can feel, or it's felt for probably the last 2 years, like you're just coping with the next thing, and that our focus can be constantly drawn to the things that are changing, and how do we react to the changes? And you'll be well aware of what many of those things are. What I'm hoping to do today is to allow us half an hour on a Saturday morning to acknowledge the changes, but then also think about what's not changing. What are the important things that we don't want to change? And just as a spoiler alert, I'll be sharing some of the things that I think matter the most, but I'm not going to be telling you what should matter the most. And I'm not really going to be telling you what you should do either. But my hope is that you'll come away from this with uh, hopefully some encouragement and some things to think about, and also maybe some things to talk about with your colleagues to kind of to find your anchors through this time of change. I'd like to thank Jared for beginning with the karakia. So I won't do another karakia, but just to acknowledge that um, we're here on our Saturday mornings, and it's amazing that you've even shown up when there's many other things you could be doing. So thank you, and also to acknowledge those of us who are thinking of loved ones or people far distant who have passed away, and that's going to evoke different things for different people, but something we all share in our lives. I so I'll introduce myself. No Ingarani oku tupuna, ko Pākehā te iwi, no here taunga ahau, ko Rudolf Steiner te kura, ko Ototahi te kainga, NINA, ko Puking ahau ki te whare wānanga o Waita. So in Pākehā, I went to a Steiner school for my own schooling, which was interesting and had no formal assessments. So I therefore left school with no formal qualifications. I have been a maths teacher in high schools at Taua College and Onslow College, which some of you will know if you're from the Wellington region. I taught for about 4 years, so I'll start by saying I'm not an experienced or expert maths teacher, but I am a maths teacher and still a registered teacher. My main work now is research and teaching, and my research focuses equity and mathematics education with two main streams, no pun intended. One of them is working with schools that are moving away from streaming to support them to do that well. And the other is with Mathscraft New Zealand, looking at the way they're using crafts and other interesting ways of making things to learn mathematics from people who just show up at a festival and might not have any professional connection to mathematics and not think of themselves as mathematicians to advanced mathematics students. Um, and I just want to acknowledge you for showing up, and amidst everything that's happening, amidst industrial action, there's a lot of other demands on all of our time. So thanks for being here. Um, okay, so the structure of this is basically to identify some of what's changing. That's probably not going to be news to you, but then go a step deeper in terms of analyzing, well, how do you characterize those changes? If you look at it from a higher level, what's the change that matters and what's the change that's kind of superficial or a renaming of what we already do? Then I'm going to look at some of the potential unintended consequences of those changes. So part of my work is in courses where we learn about assessment, and so we learn about the intended consequences of assessment, what's it meant to do when it's working well, and what are some things that happen when we assess, particularly when we assess formally, that weren't the intention of the assessment, but we still need to know about, and we might need to mitigate. I'm then going to introduce two things that matter to me, and spoiler alert, they are in the title of the presentation, and look at how we can hold strong to those, and even how we could use all this change as an opportunity. And I know that might sound naive, and I acknowledge that there's no getting around the fact that changing systems and changing structures mean extra work. But what can we do with that? So I know there's lots of changes. There's curriculum changes, there's changes in school inspection, but I'm focusing on assessment. Okay, so what's really happening? In years 3 to 10, there's going to be a twice yearly project progress check from 2026, which looks like it's going to be an online test, which is currently contracted out to an Australian company. And that's going to be the same test across all schools. So this affects primary and secondary. There's the new, and I'm talking about proposed things as if they're happening. They may not, but that's how I'm working here. So there's the proposed foundation award in year 11, which looks like it will probably be a test. There's the proposed New Zealand Certificate of Education, and the new subjects just released a few days ago show that in year 12 they're proposing maths and applied maths in year 12 from 2019. So those will each have their own assessment. Then the New Zealand Advanced Certificate of Education with 4 subjects within maths, applied maths, further maths, and statistics as data science has 4 different mathematics courses available in year 13, alongside mathematics being compulsory in year 11. So this is a really drastic and probably once in a generation change for primary, because in living memory, no one I talk to remembers a time when there was compulsory statutory assessment in primary schools in New Zealand. Of course, we've always assessed, but different factors come into play when schools are required to test, when they're required to use a particular test and report it in a certain way. And we've seen that it's not a new phenomenon. It's not new internationally, it's just new in New Zealand. So we have examples we can look at. Okay, so that was a very brief overview, but what does this mean? What can you say about these changes? Well, the year 3 to 10 changes, it's not necessarily that there's more assessment, that students going to school are going to be assessed on their mathematics learning more often. That's going to depend on the school. It's probably not that unusual to test more than twice a year already, right? But the difference is that it's mandatory and it's standardized. So not only standardized against, we don't really know yet, maybe the curriculum, maybe age level norms, but also standardized in the sense of being the same test. And it's interesting that we've seen this shift from you can use PAT or you can use EASTL to no, we actually want just one test. And I don't think that's because the new test is going to be somehow better quality. I think the government's been fairly open that they want to be able to have one measure that's comparable across all schools. Increased scrutiny of assessment results. There hasn't been too much noise about this, but one of the 4 pillars of the government's maths education strategy is accountability. They've said that the Education Review Office will be needing to act more quickly when schools are underperforming, however underperforming is defined, and it suggests that having a standardized assessment system across all schools might be one of the tools for identifying what they would perceive as underperformance. And the other major change in year 3 to 10 is arguably, maybe not that arguably, a raised bar. If we compare the new year 0 to 8 curriculum and the proposed 9 to 13 curriculum to previous curricula, there's harder maths in there at each year level. If we look at senior secondary, we now have a high stakes gatekeeping test. And when I say high stakes, if you fail this, you're failing year 11. So we've kind of seen this already in the NCA co-requisite. But again, it's quite different to what we've had for quite a number of years where, yes, there's a numeracy requirement for getting any level of NCEA, but the way in which that requirement is met was much more flexible, had more opportunities for reassessment, as opposed to being a one-off event under assessment conditions with a clear binary pass-fail at a particular point in time. So that we'll look at what some of the implications of higher stakes can be, both for students and for teachers. There's a lot of, with the proposed NCEA changes, there's a lot that I think is a little bit superficial. It's not going to make, I don't think it's going to make a huge difference to the lives of students or our work as teachers, other than a little bit of change to go from achieved merit and excellence to A, B, C, D, E, and percentages. I mean, but what is a fundamental change is there are distinct subjects as opposed to schools having the ability to combine standards to create their own courses. So there's less flexibility. If we believe the subjects that we've seen in the proposal a few days ago, then, for example, in year 12, you've got maths or you've got applied maths, and you need to choose one of them. You need to do them the whole way through, and you need to do all of the assessments within each of those courses, including the exams. So that's much less flexible than what we currently have in NCEA, and I would argue that that's one of the more fundamental changes that's proposed, is taking the whole course, doing all of the assessments. So what could possibly go wrong? In other words, what are some unintended consequences here? And I want to start this by saying that none of this is an accusation. Where I'm coming from with this slide is to look at mainly international examples of where an education system has transitioned to more high stakes assessment and what's been observed following that change. This doesn't mean that I think any individual will do these things, but I think it does give us some flags of what to watch out for and what to think of ways to prevent. The other thing I want to say before this slide is that I know there are what could possibly go right. Like, this is obviously a negative, asking what could possibly go wrong is obviously a negative way of framing this. And this is not because I don't think there could be any positive consequences of clearer reporting to parents, all the things that are being used to justify the changes. I'm not saying none of those have any merit, but I'm saying that as teachers, we need to think about what could go wrong so that we can start to mitigate some of those potential unintended consequences. Okay, so when you have higher stakes tests, you have a higher level of test anxiety. Stereotype threat, which I'm going to get into in more detail in the next slide, where if you're a group that is negatively stereotyped in relation to a particular activity or domain of knowledge, so for us learning maths, then that can actually have a negative impact on assessment results, which undermines the validity of the assessment, even if it's well designed. Curriculum narrowing. So, and we've seen this in New Zealand as well with national standards, and it's a rational response to high stakes, right? Because we want to support our students to be successful in the system that they're in. But what I mean by curriculum narrowing is that what gets taught focuses more and more on the things that are going to give the students the best chance of achieving well in high stakes assessments. And that it can seem like it's a negative thing, but it also comes from a place of wanting to support our students to do the best. So in some ways, it's a really rational response to high stakes assessment. It's particularly, I don't know how many people, how many primary teachers we have in this group, but I think it's particularly relevant for primary. You know, a maths teacher, a high school maths teacher is always going to teach maths. That's what you do. But in primary, even with national standards, we saw a shift towards spending more time on maths at the expense of other subjects, which is what I mean by curriculum narrowing. Effects on learner identity. This is, to me, really important, maybe one of the most profound impacts of increased high stakes assessment, but also one of the more difficult ones to quantify, where there's a huge amount of research internationally about the way it makes you feel about yourself and the way it makes you perceive your own capability in a particular domain, like mathematics learning, if you're getting an official statement labeling you as unsuccessful. Educational triage and strategic course allocation. So this is where things get a bit messy. There's a lot of evidence from the UK, for example, about educational triage, which is where there are these really important grade cutoffs, where if a student meets a certain grade, then it might affect which school they're able to go to subsequently or the types of courses they're able to take. So we have an assessment partway through schooling that has consequences for subsequent options or opportunities to learn. And schools focus very strongly on supporting students who are sitting just below a crucial grade cutoff, but less so on those who are looking like they're comfortably going to pass, and less so on those who seem beyond hope. And of course, when we hear that, we think, no, I wouldn't do that. And my point is not that you would do that. My point is that this is what's happened in other places where high stakes grade cutoffs are introduced, is there's a strategic focus um, on those who can be pushed over that high stakes cutoff. Strategic course allocation. I was talking to a colleague in New South Wales a few days ago, and they have a greater number of senior maths courses, including, I can't remember what it's called, but advanced maths or further maths or something like that. And what she was talking about was schools that have to make this really tough decision of whether students should do a more advanced course with a higher probability that they will fail or an expectation they might get a lower grade in that course, or do a less advanced course with a higher chance of passing and a better chance of getting a top grade. And we've always had that to some extent, but these distinct course pathways, I would say, make that more pronounced. I just wanted to do a brief deep dive, if that's not a contradiction, in terms on stereotype threat. So of all those bullet points, it's just one I want to expand on slightly further. And this is the university lecturer and me coming out. So sorry about that. We've got a definition here, and I'll give my voice a rest and let you read that definition. So relating that to myself as a white male, I'm positively stereotyped in many ways, but the one that comes to mind most easily is the incompetent dad stereotype. So I have 3 young children, and there's a stereotype that dads are fun but incompetent, especially with the youngest children, especially with babies and toddlers. And so if I take my kids to school, but I've forgotten their lunchbox, that's happened. Or if they've got a stripy top and patterned pants, or they're dressed really terribly, then I feel like that it's not just a personal failure, it's me failing as a dad. It's me fulfilling the stereotype of dads that are just don't think about these things, don't carry the mental load of young children, and so we get it wrong. And so that failure kind of comes with different connotations. And I'm sure we can imagine how that can apply to different areas of academic learning where certain groups are stereotyped in certain ways. There's not much we can do about the fact that stereotype threat exists, but there are factors that increase and decrease its salience. So let's look at some of those. So stereotype threat is most pronounced in situations where the task is challenging. So if there's a really easy aspect of looking after my kid, like taking them to school at all because I live just down the road, then I'm probably not going to fail at that because it's just easy to do. The stereotype is activated or emphasized. Okay, I'm going to switch from parenting to maths now. So in what situations might the stereotype be emphasized in assessment situations? There's a perception of being evaluated. The task is directly related to the stereotype. So I'd say coming into a room and sitting a formal maths test under assessment conditions, especially if it's a challenging maths test, is prime conditions for stereotype threat to uh, be quite active, and for students who either for whatever reason see themselves as incapable mathematicians, or in, for example, a gender or racial group who are not stereotyped as the most mathematically capable, then this is likely to be activated and is likely to affect assessment validity. These all sound negative, but let's try and flip them, especially the last one. You feel like an outsider, because that's where we have most influence as a teacher, is we all know the things we can do to have our classes feeling like healthy communities of learners, where we minimize judgment, where we value multiple ways of succeeding in multiple types of confidence in mathematics. And it's all those things that we can affect that are going to mitigate or reduce stereotype threat. It's also in how we interpret and how we talk about the results, that they're a progress check, they're to support your growth, and that they're not a judgment. But that's the message we can give, but it's a harder message for students to believe when the tests are higher stakes. And I think we need to acknowledge that reality. Okay, so we're gonna go into breakout rooms of 2 or 3. So I want to give you a moment just to process some of this. And what I'm asking you for, you can talk about whatever you want. No one's monitoring you. But here's some suggestions anyway, is that you do at least one of these. So a response to anything that I've said so far, something you might have agreed with or disagreed with, an implication. So something that this kind of made you think about in terms of implications for your own practice, or a complete tangent. So this made me think about that, but it's a bit of a leap. And we'll say 5 minutes. Hey, so I'm not gonna do whole group feedback from that discussion now. I'd like to leave a bit of time for discussion at the end, although it's taking longer than I was planning. Let's keep going though, because um, what I want to encourage, if there's one thing you take away from today, it's to do a slight shift from, like I said at the start, from focusing on all the things that are changing and how we cope with the change, to what are the things we don't want to change. Or to use another metaphor, I feel like I'm hearing a lot these days, let's not throw the baby out with the bathwater. So let's be a bit precise about, well, what is the baby that we don't want to throw out? And I think of this partly from my role as previously a teacher and in teacher education, but also as a parent, kind of what do I hope that my children are experiencing when they do maths at school? And for me, or when I was a maths teacher and now in initial teacher education, what do I see as my kind of core responsibilities? What are the things that mean I'm doing what I need to be doing? And for me, one is rigorous mathematics learning. I feel like that's a bit of a no-brainer. We need to be supporting our students to achieve their potential in maths as a maths teacher specialist, or as a teacher of maths amongst other subjects in primary or intermediate. And the other one for me is joy. So both as a teacher and as a learner, and I think they really go together. There's quite a strong correlation between the moments I'm enjoying myself as a teacher and when students are enjoying themselves learning mathematics. So neither of those are particularly revolutionary, but I'd like to talk about each of them just briefly. Okay, so firstly, holding on to rigor in mathematics. So firstly, I'd like to say that I don't think any teaching approach has a monopoly on mathematical rigor, and where there's been a lot of debate, which I guess has been spurred by these changes, and so it brings it to the surface of, what's more effective, uh, explicit teaching or discovery, things like that. There's been a lot of debates around that, and I think if we look back at, so I think case studies are really important. You can look at large correlational studies and say, is one one more effective than the other, but also as kind of an individual working in a particular school, in a particular context, it's important to look at case studies of schools that have been documented to do a stunning job and to help their students achieve at really high levels in mathematics. And you can find those across quite a wide variety of different teaching approaches, some of which are more orientated towards what you might call a progressive curriculum, more discovery learning, more use of rich tasks and heterogeneous groups. And you can see examples of that with a more back to basics approach of a lot of explicit teaching, lots of practice time. So there's no one way, there's no one magic bullet, right, for supporting rigorous learning. But as a tool to think about, I've put a table here, which is one of the many I guess, typologies of thinking, and there's Bloom's taxonomy, there's many different taxonomies. I'm not saying this is the best one or even the right one, but it helps us think about what our students are doing. So I feel like it's important for us to think about what types of mathematical thinking are you making space for, and probably explicit teaching the approach that's being advocated in what's come to be called structured maths probably works quite well at some levels of this taxonomy and less well at others. So one consideration in holding on to rigor is how are we hitting different parts of this? So are we supporting our students to remember basic facts? Is that important? Absolutely. Are we supporting our students to be creative when they encounter a difficult problem? I think that's also important. Are we teaching them to apply learning in new and novel situations? Are we teaching them to evaluate whether the methods they've used make any sense? And there are possibly different types of tasks that are better at supporting different types of cognitive processes. So in some ways, I'm just trying to hedge my bets here, but also I think genuinely there's just space for diversity in the types of things we do, and that's healthy. I'm actually going to skip this slide because of time and move straight to holding on to joy. I'll go back if we have time, but I want to leave some time for discussion. Okay, so holding on to joy. First, I'm going to start with a question. When do you experience joy as a teacher of maths? What are the times when you're enjoying your job? When do you think your students experience joy? And I just want to give two examples here. They're not exhaustive. They're not necessarily even the best examples, but I've become involved kind of from an educational research perspective with Mathscraft New Zealand, who you may or may not have heard of. That's fine, but they run these festival events is one of the things they do. So it's not even in a school where parents and kids can come along and do these different activities. One of them you can see an image of there. It's kind of a pseudo fractal. It's a Mega sponge, and it's made entirely out of business cards with no adhesive, so there's no tape, no glue. You just fold them together. So you fold 6 cards together into a cube, and then you make 20 cubes and join them together into a level 1 Mega sponge. And collectively, once say a class or a large group of people has made 20 of those, you can join them together into an even bigger one, which is about 1 meter tall, and it's incredibly joyful, but it also involves learning about fractal concepts. And the Mathscraft New Zealand team, who are pure and applied mathematicians at Canterbury University, have started to use these types of approaches in their university mathematics teaching as well. So I think sometimes we think of these things as more appropriate for the earlier years of learning, but they have been bringing that joy of discovery and making it even into, advanced third year university topology courses, which I think is pretty cool. For me, there are some rich tasks that I use with my initial teacher education students that consistently bring a sense of joy, and it's not because there's anything special about the way I teach. It's about the task, right? So I'll show you briefly what this is. You may have seen it before. So you start with 5 number cards, 1, 2, 3, 4, and 5. You put them in the shape of a V, and a magic V has each arm of the V adding to the same total. So it's this amazing task where the required background knowledge is being able to add single-digit positive whole numbers, but the endpoint almost nobody gets to. Even, and, you get the people coming in because some of the initial teacher education students in primary have a mathematics degree or might have worked in a job where they were doing really advanced mathematics, and they want a formula. They're like, I want to work out, well, if we did the numbers 1 to 11, surely you must be able to create a formula for working out how many different magic V's there are. And well, I'll leave that up to you. But for me, those are some of the times that I find joy in teaching, and my students find joy in learning. And so for me, those are two anchors. If we think about everything that's changing, there's a lot we need to be changing in initial teacher education as well. We're kind of adapting to, okay, so how do we prepare students for this new curriculum? We're being asked to provide evidence of how we're integrating cognitive science into our programs, which, spoiler alert, is not a new thing in our programs. But to me, so these are some anchors I hold on to. There are some things we've always been doing that, whilst we need to engage with and think about the things that are being proposed, there's still a lot that's at the core that's not going to change. So I'm going to ask you to, given that it's 10:43, Jared, I'm wondering whether we aren't actually able to go into breakout rooms again. We're pretty much aiming to wrap up at 10:45, is that right?
Yeah, it's probably best. Sorry, David.
Yeah, no, that's all good. So what I'll ask you to reflect on then and discuss with colleagues, mull on over your morning coffee, is what are you already doing? What are the things you want to hold on to ensure rigorous maths learning for all and joy in teaching and learning of maths? Or what else are your anchors? There might be different things for you that you think this is the thing, this is the baby I don't want to throw out with the bathwater, this is what I want to hold on to through these rapid changes that are happening in maths assessment. So finally, I want to say that what's changing is less important than what we want to retain. So yes, there are things we have to cope with, there are things we need to deal with, but there are things, the more important things are probably going to be the things we're not changing. I'm going to stop there and thank you for engaging with what was a little bit of a rant and more a provocation than a presentation of content, but I hope that it's at least sparked some useful ideas or questions or discussions you could have with colleagues to stay strong and stay anchored amidst what can feel like a quite disorientating period of rapid change. So I'll stop there.